In this tutorial, we're going to be building a custom mesh pattern and then mapping it onto a lofted shape. The pattern will be easy to control with some simple sliders. There is a starting file available for Rhino, so you can create the exact same loft shape with the curves provided here in the loft curves layer. Go ahead and download the Rhino file, open that up, and open a new grasshopper file. The basic pattern that we're going to create looks like this. It's a very simple mesh with a couple of triangle faces. To set up our basic pattern, we're first going to start with a rectangular grid. Our rectangular grid by default is on the world XY plane, but by adding a XY component, we can choose to turn off that preview and just focus on our grid. Now, our basic pattern was quite simple and we only need a grid of 2 by 2 rectangles. So the extent in the X and the extent in the Y should both be 2. I know that this value is never going to change, so I'm not going to use a slider, but I'm going to use a panel instead. To quickly create a panel with the number 2 inside, I can type in a quotation mark, followed by the number and hit enter. Let's also add a slider for the size in the X and the Y direction, just so we can make it a bit easier to see. To create our pattern, we're going to be working with the points in this grid. So the points are here in the P output. We're just going to add a points component to make it easier to see. And I'm also going to add a point list component so we can see the order that these points are in. Let's increase the size so we can see what we're doing. So as you see, this is quite a complex data structure. There are 3 different lists, with each of them have 3 different numbers, or 3 different points. We can go ahead and flatten this list because we just want all of our points to be in one big list. So now you see it starts counting at 0 and goes all the way up to 8. We want to use these points to create a mesh. So let's add a construct mesh component. If we take a look at this construct mesh component, you will see that it's asking for a list of points. It's asking for a list of faces, and there's an option to add some color if you want. Now, we've already created our list of points, so we can go ahead and add that into the vertices component. And now we need to specify the faces. The default setting here is a quad face, which means it's connecting 4 points. But like we saw in the pattern, we are looking for triangle faces. So we need to connect 3 points into a triangle face. The definition for a triangle face, we can go ahead and type that into a panel. Looks like this. Starts with a T, then there's an opening brace, followed by the numbers. So for example, 0, 1, and 3. And then there's a closing brace. If we add this as our face definition, it will give us that first triangle face. In order to create the texture in this grid, we would have to add all of those triangle faces that we're trying to create. We can make this process a little bit quicker by adding a concatenate component, which allows us to combine different panels into one string of text. So I could add a small panel that has the T and the opening bracket, and I could create a small panel that has the closing bracket. And combine them using the concatenate component. In the middle panel, we want to just have the numbers. So to combine these 3 panels, we first need to zoom in on our concatenate component and hit the little plus to add a third input. Now you can go ahead and add all of these panels together. And you will see that the output looks similar to what we had before. By right-clicking on this middle panel and switching off multi-line data, we can now use this middle panel to fill in all of the numbers of the triangles that we're trying to create. You could go ahead and just type them in. For example, 1, 2, 5. And keep going like this to create all of the triangles that we need. We've also provided a list for you in the lesson materials that you can copy and paste into this panel. Make sure when you're typing in your panel that you don't hit enter at the end, because that will create an empty space, which can cause some errors in your mesh. So remove the extra enter and just click outside of the panel to close your panel. So double click to edit your panel and just paste the list of numbers that we've provided. And you will see that now your whole mesh has been completed. If you don't see the lines on your mesh, make sure that in the display options in Grasshopper you have the preview mesh edges turned on. If you don't have that turned on, it might look like squares to you, so make sure that that's turned on. So we have our basic mesh. Let's try to clean up this script a little bit. So we'll add some scribbles to make clear what each section is doing. So this one is setting up our grid. Here we have our number preview. In this section, we're setting up the triangle faces. And at the end, we're constructing our mesh. Now, the pattern right now looks very flat because we haven't moved any of the points yet. So that's going to be the next step, creating a little bit of a more interesting pattern by moving some of the points up and leaving some of the other points where they are. So the points that I want to move up are the one in the middle and the corner points. As you will see, that is quite a logical pattern because we're just moving every other point. So point 0 we're moving up, point 1 we're leaving where it is, point 2 we're moving up, and that goes all the way. So this means we can use a simple pattern of zeros and ones. So let's add a panel. Double click to edit and just type in 1 and on the next line a 0. Click next to it to close it and make sure you switch off that multi-line data. We're going to use this pattern to move some of the points and leave some other points where they are. We know we want to move them up, so that means we need a Z unit. So in order to be able to use this pattern, we need to make sure that this pattern is exactly as long as this list of points. So we're going to add a repeat data component. The data we want to repeat is our list of ones and 0, and the length of our list is the same as our length of the list of points. So we can simply add a list length component. Analyze how many points are on this list, and use that as our list length for the repeat data. We could go ahead and use that as our input for our Z vector to move our points. But then the points will only move up by 1 because 1 is the number that we specified. Instead, I'm going to add a multiplication and a slider so we have a little more control. So we're going to multiply this repeat data and use that for our Z unit. So now we have full control over how high or how low we want our points to be. If we have a look at this list of points that we just created, the new list of points, you will see that the order hasn't changed. So we still have our first point here in the origin and then moving all the way up to point 8. So that means we can simply replace this list of points that we created here in our mesh with our new list of points, and the mesh triangles should still look the same. So we've created our basic pattern that we can change with this slider. Let's give this slider a name, so it's easy to find at the end. And let's group all of this together and also give this section a name. So after creating our basic pattern, we can now go ahead and create our loft. Let's, for now, turn off the previews for everything in the section that we created first and move on to the layer with the loft curves. If you switch that on, you will see there are 4 curves provided that you can use to create a loft. Let's add a curve component to import them into Grasshopper. Right-click and click on Set Multiple Curves, and then you can go ahead and select all of them at once. You can also select them one by one, but make sure you do it in the correct order. Once they have been imported into Grasshopper, you can switch this layer off again. Now, these curves have been prepared in such a way that you can go ahead and loft them straight away. You don't need to fix or troubleshoot anything. So add a loft component and have a look at what that looks like. The seam line should be straight along the side. And it should read untrimmed surface in the Grasshopper component. Let's add another surface component to make clear that this is a surface we're working with. And let's go ahead and reparameterize so we know the domain of the surface is going from 0 to 1. In order to make an interesting pattern on this surface, I have to divide the surface into smaller surfaces. And then each of the surfaces will have the pattern mapped onto it. Turn these previews off. And we'll add an isotrim component. Now the isotrim component will ask for a domain. So we'll use a divide domain component to create our domains. The divide domain component asks for a base domain, which is the domain of our base surface. And then we can add some sliders for the U count and the V count. You can simply copy and paste that slider. And I recommend starting with a quite small number so it doesn't get too heavy on your computer. Add that as our domain, and now you will see the surface has been split into separate surfaces. It will also show up when you hover over it in Grasshopper. You'll see that I now have created 9 surfaces. Now, on each of these 9 surfaces, I want to find 9 points that correspond with the points that we created in our pattern. To do that, I'm going to use a surface frames component. We can add our surfaces in the top input and then specify how many points we want in the U direction and how many points we want in the V direction. In this case, I need those U and V values to correspond with my grid that we started up with here. So I'm going to copy the value that we used here. And make sure that each one of these surfaces that we created has those 9 points on it. Now, before I can use these frames and the points that they correspond with, I need to make sure that the data tree looks similar to what I'm looking for. As we saw before when we worked with this simple list of points, I put all of the points into one list. I didn't want them to be in separate lists of 3, but I wanted them to be in one list of 9 values. If you look at these frames here, you will see that they're now in separate lists with each list containing 3 frames. I don't want to flatten this because then everything would be in one list, but I do want to simplify this data structure. To do that, we're going to use a trim tree component. Now, by trimming the tree, you will see that now I have my lists of 9 points. So each surface has its own list with 9 points, which is exactly what I'm looking for. I'll add a plane component to make sure it's recognizable that we're working with planes here. And we can go ahead and add some scribble text. Let's switch these previews off and just keep the final planes turned on. Planes are a very useful tool because they don't only have a point, a center point, but they also have a direction. So we can use the normal direction of that plane to create our pattern that's following the shape of our surface. So let's deconstruct these planes. So we can separate their z value and their origin value. So we have a point and we have a direction. To make that clear, I'll add a point component and I'll add a vector component. We're going to use these points and these vectors to replace the vector that we have here and the points that we have here. So let's create some space in our script. I'm going to select all of these components and move them over, holding down Shift to move them in a straight line. I want to use these points in the same way that I used these points before. So I can go ahead and hold down Ctrl Shift to grab these outputs and put them in these points instead. Of course, you can also just go over the lines to replace them. So make sure your points are now connected to the list length and to the move component. Next, to replace the Z value with this set value for our frames, we're going to add another multiplication. So instead of using this set value here, we're now going to multiply this value with our vector and use that as an input for our move component. Add that in here, add it to group. Set value isn't really doing anything anymore. So now if we turn on the preview of our mesh, we should have something like this. It looks like the loft shape, but it's very crude. It doesn't have a lot of triangle faces. And that's because we left these values quite low in the beginning. So now we can go back and turn them up a bit. Can also go ahead and turn these previews off so we don't see all of the frames and we just see the final shape. So let's add a few more frames. If you hover over this mesh output, you see that actually we've created a lot of separate meshes. So we need to clean up this mesh and combine them into one mesh. To do that, I'm first going to add a mesh component and make sure to flatten so we get rid of that complex data structure. Then I'm going to add a mesh join component, which is going to add all of those separate meshes into one big mesh. We can hide these previews. Now, one more thing, if you would bake this into Grasshopper, it's easier to see. You will see that we have some dark lines here and there's some lighter lines. These dark lines are nice, crisp edges, but these ones will be a bit more difficult to render and might look a bit weird. If you look at the reflection, then you see it doesn't look quite as nice. So what we're going to do to fix that is we're going to add a unweld component. with an angle of 0. And that's going to make sure that all of our edges have those crisp lines. So now you see all of them are those dark black lines. So we have our final mesh. Let's make some nice renders of it. We will add a custom preview component. And we will create a custom material. So create material component. So we can add our base color and then a couple of colors for the highlights, the lowlights. You can specify the transparency and you can specify the shine of your material. I have created a couple of example materials that you can download from the lesson materials. I'll just copy and paste them for now. And we can have a look at what our shape will look like. For example, I can add in this iridescent material, which has some nice shine and some nice definition. You will see that the highlight color is green here. Or I could, for example, add some clay material, which doesn't have a highlight color and isn't shiny at all. Or maybe you want to create a metal material, which has a lot of shine. Now, another thing I want you to try out is to look at the loft surface examples layer. If you preview this layer, you will see that there are a couple of shapes in there. And we can test out if our pattern works on each of these. So all of these shapes are single surfaces. So if you click on them, you will see this is a surface. This is also just a single surface. This is a closed surface because its seam is touching back to itself. And this one is also a closed surface, but it is a single surface. So if you want to import these shapes, you can go back to the beginning of your script, add a couple surface components. Right click them, say set one surface. And then you can replace the surface that we had created here with these new surfaces. So for example, you can have a look at what the pattern looks like on the cylinder. Maybe you want to tweak the pattern a bit with these sliders. You will see it also works on our sphere. Might have to hide these to get a better look. Hide these previews as well. And it even works on that complex flower-like shape. You will see if you show those preview shapes again, press F10 to turn on control points. You will see that even if you move these points, your pattern will always keep following that shape of your surface. Now, if I wanted to make a nice render of this cylinder shape with our pattern, I could go ahead and bake our final object, so our custom preview. Right-click it and click on Bake, specify on which layer you want to bake it, and then you have your final shape here. You will see in Rhino that it tells you that this is an open mesh because the top and the bottom aren't closed. And if you go over in the Properties tab to Materials, you will also see that the material has been baked with it. So we have that color that we selected in Grasshopper, we have that highlight color. You can add some reflectivity, and you will see that material show up when you go into rendered mode. So to recap, we looked at how to set up a simple pattern with a rectangle grid. We looked at how to define the triangle faces. We divided a lofted surface into smaller surfaces that we could use to map our pattern onto. And then we combined all of that into a constructed mesh, which we fixed and rendered.